Hello, everyone. Welcome to supporting low memory targets in Unity3D. This talk focuses on the work that Necrosoft Games has done in porting Gunhouse to Windows Phone. As a quick index of what I will cover, I will explain Gunhouse because it's not been available in large platforms altogether. I will quickly sum up why we need the low memory devices in Windows Phone, and then I will start describing how we changed the original architecture to Unity3D. The paradigm change, or meaning how we actually modified the previous engine to work on Unity, and what changes did that took to the engine itself, and why is it good. And then I will just discuss the content resources, the management that we do, so that the application can still run under the low memory requirements, and some very basic thoughts about garbage collecting and gameplay, because garbage collecting is still very important for C# code, and in particular in Unity, it's somewhat restricted, or at least it's not as good as I would like. And then some final thoughts. So I am Nuno Antunes. Sometimes I am called Takashi from the old times of the internet, when that was a thing that could happen. And I've been working for Necrosoft Games, doing the Gunhouse. I started doing enemy AI, and then I finishing doing the ports and extra features that we wanted to add for the Windows Phone. Right, so what is Gunhouse? Gunhouse is a fun and challenging puzzle game with tower defense elements. So it basically mixed, it was actually born of a game jam, based on an idea by a Twitter account called Peter Molyneux. And it was also developed by Jim Crawford, that you might know from the Frog Fractions, and Frog Fractions 2, soon, maybe. And as well as music, it's not there, but it has music by Disaster Piece, so it's a rather interesting and made by some very talented persons, and I'm very proud that I was also able to work on this project for a little while. The platform selected, though, it was the PlayStation Mobile. It's a specific subgroup of games that are available for the PlayStation Vita platform, and for selected Android phones, I think, still. Meaning it's no longer something that Sony supports at all, and that is the start of the problem. Anyway, mobile SDK is C# based. It runs a somewhat older version of the C# mono runtime that Unity uses, a very, very, very old version. That brought us some problems. I have a trailer of Gunhouse, because how many people have actually seen or played Gunhouse? Yeah. So I will just demonstrate the gameplay. So as you can see, the game itself is reasonably simple. So it became a very good candidate to show around, and eventually got a deal with Microsoft to do actually the port to their Windows Phone platform. When I started looking into the port, it quickly became apparent. By the way, I actually worked for Nokia for a couple of years, so it wasn't really apparent as immediately obvious that a lot of the Windows Phone platform is a 512 megabyte RAM phones. They are not very powerful, especially compared to what you can get with an Android or what you have on iOS. You just simply can't challenge these devices with the same amount of graphics quality. And in general, they also have slightly older CPUs, slightly lower end Adreno GPUs. So it sums up that you are limited by two things. First is low memory in general. And second, the GPU itself is not that good at pushing triangles or actually doing a lot of shader work. So you are cut down on that side. In addition, because of Windows Phone in particular, you have a very strict limit of memory that you can use. The actual documentation says that you have 180 megabytes to develop a 512 megabyte. You have 180 megabytes to develop an application for a 512 megabyte phone. In Android world, this isn't that straight. You can, depending on what application is running, you will have more or less resources. And if there is no resources, it will create them when needed. And this causes a bit of a problem. This value is even actually higher than you get in Unity. The Unity documentation says 133 megabytes. My experience is once you get 60 megabytes, 80 megabytes, it will start to do something, either garbage collecting or some sort of swap will take into action, and it will simply slow down the game. And that is not something that we want. It's not a problem if you have a 1 gigabyte phone, at least for these applications, because 380 megabytes. And it's also a fact that a lot of games in the Windows Store won't actually support 512 megabyte phones. And I'll talk about this a little bit later. So what could we do about this? So originally, the PSM SDK has a very bare bones structure. So it provides you with the old API. You can do graphics on it, but you only have the most simple configurations possible. So you can, say, push triangles to the GPU, load textures, manage sound, but everything is no overall. So what happens is the state management, the levels, how to render your triangles, how your resource is made, everything has to be done by you. And that's what we did. Well, what SimCorfo did. And in addition, it also splits memory equally for some reason. So the specific Vita version of PSM splits between 96 megabytes for the CPU in RAM and 96 megabytes of GPU texture memory. Unity3D. In general, I hope everyone knows more or less how Unity works. So you have this nice interface. You can create scenes. You have lots of features to render. You have the very powerful and very useful game objects. So it's perfect to create a game. But we couldn't actually use all the features. And I will try and describe why. So the main question is, should we remake the entire game in Unity? First, this was a port. We didn't really have time to get all the resources. So, for example, the resources were made using a loader that was what was made in C#. And we used a lot of, you modified it a lot. So for enemies, sometimes you use the special calls and special animations. That wouldn't be possible if you, we would have to recreate using Unity. a lot of the engine itself, it was already made, and it had the characteristics. So it had a special collider that it was written by us. It had special animations for gravity and everything. We didn't want to lose everything or rewrite everything to Unity. First, because we didn't have the time, and to a point, it was the game would actually. There was a possibility that the game would feel different, at least, in a gameplay point of view. So there was really no reason why we should spend this amount of resources, and not to mention testing, post-testing, a new version of the same game that you already had. What this means is that the whole entire port runs in a single scene in Unity. We create a MonoBehavior, and that attaches to the game object, and then we just use plain C#, that is basically a modified ported version of the game itself. This is not that unusual in game ports, but I never actually saw anyone admitting that they do this. So that you have a Unity game, but actually the game itself is not running in Unity. It's just simply using Unity as a gateway into all the other nice things that Unity gives, like porting to multiple platforms, or having access to a slightly better runtime of mono runtimes, and so on. Of course, the problem is this all needs to be stable at 151 megabytes. So why I talk about this is that when we did this, we lost the capacity of Unity to split nicely the resource loading. Because the great purpose of scenes in Unity is that you just pick what resources you want, and when you leave or enter a scene, you are performing a sort of memory management by itself, because Unity knows it has to load this scene and take this scene. We couldn't afford this. This made that we had to work out with some more primitive ways, or at least more original ways, let's not say call it primitive, of memory management and resource allocation. So, for the start, we have the main problem was that the game itself would run. You can just attach it, create the class, and run it from the outside. So you could have the entire game logic running, but not seeing anything. So when we got to that point, we just wanted to show graphics. And the PlayStation Mobile version, it had vertex data for sprites. That was basically every frame. We had a list. We cleared that list, and every frame is just loaded what each sprite had. So we created the vertexes for everything, and rotation, and everywhere, and we assigned textures to everything. And there was a special bit of magic that would let us render the identical textures faster. So it had a sort of a sprite patching, batch rendering implemented that allowed us to squeeze out the speed of the very, very slow mono interpreter. But we had to remove this. And I came up with this system where every sprite is assigned to a game object. So every game object in the scene is actually an individual an individual sprite that can make a larger enemy or object. But they are not directly related. So when I create a sprite, I don't create a game object for that sprite, because that logic is split. So let me see if I can sort the example, demonstrate here. So to the left, you can see like 9 game objects, and each game object will have data containing to a specific sprite. In the middle, when 2 sprites are eliminated, like the Gunhouse GH3 and GH5, they will vanish, and the game objects will still existing, but basically it's used as a single stack, basically. So why we do this is 2 reasons. First, I don't want to instantiate more game objects than I would like. And second, it allows us to use the sprite patching shared rendering feature of Unity. Meaning, because if you have, like, for example, bullet 0 here, instead of 2 video calls, it will just use 1, things like that. And at the same time, it still lets us use lots of the rendering tricks that we used for the PSN version of the game. In addition, it provides an interesting way out because since we don't actually have any instancing going around, this is slightly in the regular case, we would have to instantiate the enemies whenever they show up. And here, since we are constantly creating the objects via procedural meshes like this, this would be reasonably slow, what you can see in this code. So basically, it generates a mesh filter and then creates a mesh renderer. But you only do this once in, let's say, every level. So when you find out that you want to show 128 objects and you only have 127, it will create a new object and then it will create this mesh filter. However, then we added a second layer of complexity to this process. So we basically try and detect what sprites need to be updated. In this case, we basically cache all the positions and what kind of sprite it has and what kind of UV it has. And eventually, we just use the specific, you just update the game object itself with the changes. So what this all generates is that you are using much less resources to keep. You still have to keep an array and so on, but you are not actually you are not doing instancing as much as you did before. And it results in surprisingly faster performance. So, okay, this might not be something for everyone, but if you are considering, for example, making a game that has procedural elements in it, and or even if you are not considering making a game that has procedural elements in it, if you want to save memory, you can actually think a little bit outside the field of just instancing. This provides Unity, surprisingly, again, provides good performance to do things like this. And it will save you a bit of memory if you don't have to actually hand off all of your resources and so on. Speaking of resources, so due to the fact that, again, PSM, I mean, due to the fact that PlayStation Mobile version loaded all the textures at startup, and it did this because it was super slow to load the textures. They came from PNG, and they had to be decoded and pushed to the GPU memory. So you had to load everything at start. And it had a boot up time of 1 minute or something, sometimes. And that pushed 32 megabytes of texture RAM. But our Unity version not only has HD assets for pretty much everything, so it runs on 720p at least. We also added palette swaps for enemies, so we tripled the size of the assets. We couldn't do this anymore. And so we really decided to change it to on-demand call. This is actually very good because Unity is almost made for this. So we just converted all the textures to Unity format. It never gave us much of a problem. And then we just implemented the most basic concept we could find. So basically, when you create the texture or when you assign the texture itself, you just give it, just hold the file name for it, and then when needed, you push the resources load. You can do this even in games you already have, or games that you are not sure how many textures it has. Unity does this to a point, I'm aware, but by simply adding an ability to touch the texture itself on this level, and again about the creation of materials, we actually got some reasonable amount of memory out of the whole build. So from the VRAM users, we were scraping very nicely memory, and this was actually reflecting in a higher performance in the Windows Phone. What is the downside? These two things I talked, they are CPU intensive. And in the case of the textures, you have a little bit of load lag. So at the start, what was happening is that I was casting the request to the texture being loaded, but it's asynchronous, or at least not immediate. And before it was completed, it would actually show one frame of a pink square, a pink texture. That is the default Unity texture. You can actually do a little bit of workarounds for that. But it was the main question. And of course, I didn't test this for other resources. I don't know if this something like adding a specific touch feature would work for sounds or so on, or some other kind of component that you want to use. On the upside, even this little reduction in memory, is pretty valuable. And modern CPUs, even the very slow ones that are in the Windows Phone, cope with this very well. You might notice that between the old version that has a 0.5 milliseconds and a 3.2 milliseconds renderer, and the new version that has 11.2 milliseconds. Actually, that is a bit bad, worse than the average, but anyway. That has 11 milliseconds render time. This actually proved to be very unchallenging for the Windows Phone. It has a little bit other problem, but I'll discuss it later. And you can also see the number of draw calls. You can already see the batching, but for the same area of the game, you move for 296 to 16 and 79 batch. So this is also a part of the optimization that we did. Okay. Finally, this is actually pretty short because garbage collecting is very common. But in this case, because we are doing the entire engine on a single scene and so on, we need to remove the unused textures and meshes, and we needed to use garbage collecting, but we wanted to avoid as much to have it on during the action scenes because it will just break the game. So in our case, we just found the specific place, and doing it is actually 60% of the work. Knowing where you can use the garbage collecting will provide you most of the resource, most of the troubles. Okay, this got the wrong size, but the handling memory is very well covered in .NET, and the big advantage of Unity is usage of Mono and C#. So the best resource here is still Wendelin Reich's C# memory management for Unity developers. It's a 3-part Gamasutra article that is extremely valuable. if you want to learn more about it. And Unity also speaks about it a bit in this understanding automatic memory management area of the manual. It's a bit weird that I don't agree with pretty much anything in the Unity talk, other than you shouldn't run Unity, you shouldn't run the garbage collector in the middle of action scenes. But the truth is, doing this without Unity Profiler is extremely hard, and we did not have access to Unity Profiler at all times. Wendell Rice provides some other solutions, but we also, again, we didn't have time enough to finish it. So I am going to do the most simple thing. So doing a regular garbage collecting is reasonable compromise if you are in a hurry. It will clear up some space. And for us, we just using the unload and use assets was enough for us to survive. But it also showed that Unity it's actually pretty good at the 512 megabyte. It's actually pretty good at managing when you do this kind of game, and where you have to actually do a lot of texture work or a lot of resource changes in the middle of the game. There is a downside that you need to know the gameplay very well, because finding the nice spot to do it is everything for garbage collecting. And it's not here, but you due to the fact of how C# works, you shouldn't ever think that you can remove all of the bugs and problems that will arise from it. Memory allocation in C# is somewhat not aleatory, but you can just go into corners very fast. We tried many solutions actually. We even got as far as using destroy and mediate and so on. Just use garbage collecting when you know you can do it, when it feels right, when it doesn't actually affect your game. So in general, I actually had more control about how we can do this. Even if Unity is not made for this, if you are thinking procedurally, if you are thinking about doing very controlled memory management, it doesn't surprise anyone here, but Unity is not the best solution. This is what we can do with it. Okay, and final thoughts, because, yeah, all right, we're on some time. Knowing your platform is rather important. So one of the most frustrating things is that I worked very hard in getting the best optimization for the mono-based Unity build that we were mostly testing before we moved to Windows Phone. The moment I put it on Windows Phone, there was huge performance problems, including memory leaks, everything. Turns out Windows Phone uses a different mono build, and between, not actually mono build, it actually uses the .NET, Microsoft .NET version of the C# interpreter, and it actually negates most of the memory management tricks you can use on Unity. This might reflect on some other things, including if you are doing. Okay. At this point, I'm actually not sure, because Unity is always moving, and there is also actually nowadays the ability to build Windows Phone applications using the original Mono compiler. It's just it wasn't available to us. So sometimes it will just catch you and prepare. So maybe focusing on the optimizations right at the end helps. And mono CPUs can push a lot of optimization. As I've shown, I do a lot of this graphical management thing in a head. The downside is a lot of battery loss. So one of the main reasons why we use so much CPU is basically doing this, making sure that the game won't crash out of over-resourcing. In general, Gunhouse does very well for rush ports, even if you don't optimize as much as you want. we were very lucky in the expectations on different platforms. So people that used the game were happy even on the cheapest phone, in the tablets, the few tablets that use Windows Phone, or the the phablets or whatever they call them. And the great advantage of working for a deploying for 512 megabyte devices is that low-end users, they tend to be less negative. So if you put up a game for a very limited amount of people, that, for example, is like the Windows platform that only has a specific 1 gigabyte. For people that have more expensive phones or more phones with better characteristics, they might be much more demanding to a point. And we had a lot of positive feedback because we support the 512 megabytes phones. And I don't know, as an Android user, I would probably also prefer games that perform well on a cheap phone or a phone that with less features than some expensive phone that I cannot afford, for example. All right, thank you. Sorry. Okay. Do you have any questions?
Hi, thanks for the presentation. I have one question. You mentioned in the previous slides where you posted code sneakups that you somehow try to combine like mesh and apply a sprite for a mesh. So when you made your port, you didn't use the latest features of Unity3D?
I tried to use I looked into the initial features of the Unity3D, the sprite features themselves. I ended up not using them because mostly we do the game itself, or meaning the game engine itself already perform a lot of operations. In addition, the sprite class of Unity is just a somewhat more limited version, in my opinion, of the basic sprite mesh resources of Unity. This is closer to the actual to how it actually operates in the end. You know, we don't use the shader for sprites, for example. We use our own shader that performs GPU-based coloring and things like that. So in the end, there was really no advantage of using the sprite, the new sprite-based features of Unity. Sorry. And I won't say it's they are bad features. They are very useful. There is also now many ways to import animation. We used a lot of animation in Sprite. We did all the all the anime animation was done in a program called Spriter, and now it's more supported, and it is supported by Unity reasonably well. But at the time, it actually was a very early stage of the import filter, so we couldn't actually use it. And these kind of issues just accumulated to the point that we decided to go in this direction. Any other questions?
Too bad. Was just wondering if I understood it right. when you were talking about loading the textures by hand, were you loading like atlases of textures, or was every sprite a single texture?
Oh, yeah. So, about the textures. Every sprite shares, okay, every enemy shares a single sprite sheet, obviously. So, and then you have a specific set of UVs for mapping the actual sprite themselves.
Okay, so I think I got it. So it's the animations done in the sprite sheet for...
Yeah,
okay.
that's it.
One last question, because I'm tinkering currently with one thing, combining of sprites at the runtime and creating one big sprite with multiple small sprites. Do you have any experience with that? Did you try something like that?
Well, I'm not 100. Well, let me think about it for a moment then. Yeah. So if you create, if you are able to, it actually just depends on how you are actually creating these additional sprites, right? You are talking about combining a large block. So the main thing there is basically just making sure you are actually saving on the polygon count. In general, when you are doing the combination, it won't actually give you much of an edge, I think, but it will work out fine, basically, because Unity is very flexible on that aspect. Okay, but like we didn't do anything specific like that. I was very for a while I was thinking about that, because the enemies consist of multiple sprites. So maybe if they are actually attached all together, it would be faster. But it didn't seem worth the effort, because of the most sprites are very individual animated, or they are like projectiles, and they don't make much of optimization. All right. Anyone else? Okay. Thank you very much.